Alright, so welcome everyone. Thanks for joining me again in the shop. Today it's about power supplies. This is an ATX power supply from a computer, an old one. I don't know what model it is. It's old, but it still works. This is a, I don't know what brand or what style they call this. This is just a little box from an Acer Aspire maybe. This is a desktop too, both desktop PCs. And I'll show you how to turn them on. You got to connect a couple wires to make them power up. And then when you do, they're so versatile. So yeah, stay tuned, it's gonna be fun. If you like electronics and wires and stuff. So to turn on this ATX power supply, it's nothing more than connecting the green wire on the main harness to any black wire. So like I'll just pick one here, and you should see in the video the fan start spinning. I know it's kind of dirty in there, it was an old power supply. But let's touch this one right here. Where is it? There it is. All right, so now the rear fan is spinning, and that's going to supply power to all the outputs. So let's get a voltmeter on something and see if we can find the 12-volt output. So again, I just have this jumper. It's just one of those breadboard jumper cables connected to a green wire and any black wire on the main harness. I mean, it's just as simple as that. Let's see if we can find some voltage here. I'm going to look for 12 volt. All right, let's see here. Let's use a red wire. We'll switch hands. Let's use a red wire here. This is pin 3 from the top, if you could see that. And then I'll use a black wire. It's like pin 5. All right, now we're looking at 5.1 volts. All right, so that's not going to give us our 12 volt. And then we'll just keep going down. Let's try another one. 5.1. Here's another one. 5.1. What about a yellow one? There you go. So that yellow wire and that negative wire that I'm on is going to produce essentially 12 volt. It's 11.93. Let's just keep going. What about this orange wire? Okay, there's a 3 volt. There's a good one. That 3 volt would come in real handy for low voltage rheostat, or relays, low voltage relays. That'd come in real handy. Let's see if we can keep going here. Let's move. It's going to be negative voltage now because I have them opposite, but let's see what this voltage is. All right, that's a positive 3.3 volts. Keep in mind I have my leads reversed. What is that one? Positive 3.35. Positive 3.35. All right, that's interesting. There is a negative. My leads are reversed. Let's do it right so I can show you what I'm looking at. With the leads in the correct hands, negative 10.19 volts. So that's pretty cool. So if you want to get positive out of that, you just have to reverse your input on a DC circuit. That's also negative voltage. Negative 15.32. So as you can see, the point of this is to show you that you can use these power supplies, these big ones like that, to power a lot of stuff. All right, so now we have it turned on. The fan's spinning a lot faster than it looks in the camera. Probably has to do with the oscillation of the frames per second that I'm using. But I'll give you a better shot of this. Trying to keep this in somewhat focus. So green wire and a black wire. It doesn't matter what black arrow. This is the P1 harness. If yours is similar to mine, it's simple, just green and black. Let's power up this little one, and I'll show you it. So for this little power supply, it's still a green and black, and they're side by side. Yes. So I'll just try to find a way to make that stay. There we go. And then any black wire. Yep. So that fan is spinning. Let's see if I can get it to where you can tell. I know it looks weird in film, but it's actually spinning quite fast. Pretty quiet. So yeah, let's check a rated output. So just working with this just being the power for now. Let's see what I can get here on these yellow wires. Assuming yellow is positive. All right, that's a good positive 12 volts. Yellow being positive. Dropping down to that negative, same voltage. Let's drop wires. Red's on the bottom yellow now. 12 volt, 12 volt. So that's going to be just a good 12 volt power source. Output is 12 volt at 16 amp, maximum 300 watts. So dandy little 12 volt power supply. 300 watt 12 volt power supply with different output, or with multiple outputs. It's kind of cool. So here's a good look at the information panel. If you ever were to buy one of these or see one at a yard sale or something, kind of give you an idea what you're working with and what you could use in your shop. This has quite a few outputs. Yeah, I mean, you can apply it to whatever you need to apply it with. Now that we've seen this, we've powered them up, powered both of them up. Let's take this and turn something on with it. Let's turn on a fan or maybe some lights. Let's do something. For this, I have a nice little squirrel cage fan here. I'm not even sure what it came out of, but it's rated at 12 volt. And knowing that my yellow wire back here is a positive 12 volt output, just find the negative. That thing puts out a lot of air. All right, let's see if I can do the PWM fan. So this has 4 wires. This is pulse width modulated. That's how the computer controlled this fan. But you can run it on high just with its red and black. Yellow pin for my red, for my red wire, positive wire, and then black to turn it on. As you can see, it works just fine, supplies plenty enough power for that fan. But talking about PWM, the blue is not used. That's the frequency generator. It tells the computer how fast it's spinning based on the frequency that it's producing. I think it matches the input of the PWM, so it's kind of redundancy. I don't know why we need it, but this is what you'd be used if you were to hook up a PWM controller. And I had one, can't find it, or I would show you that too, but obviously that fan's good. Let's power something else. All right, so here's an example of a solenoid. Anytime that you have a solenoid, a lot of them will have a diode in place. And if you have a diode, it'll have a band around one end, a full solid band around one end. That's positive. So hooking up the positive to the side of the band, and then fingers out of the way. There we go. It's a little slow because I think my voltage is a little bit too low for this type of solenoid. Let's get a different one. Here we go with a larger solenoid, but I think it actually has a smaller current draw or current requirement. Oh, it has a switch. It has a switch, I forgot. So let's get it right about there. And yeah, there we go. That's cool. All right, so bypassing the switch, I'm gonna see if I can pull this out with one hand. It's just stuck in this connector, but let's find out. I'm curious. I'm gonna hold it on. Nope, I didn't get it. There we go. Oh no. No, I can't pull it out. Isn't that something? Switching over to macro for this shot, I wanted to be able to show you the inside workings of this 12 volt relay. Nice little relay. And they're kind of cool to see work. Then you have the coil on this side. Basically, it's just a solenoid. It's an electromagnet, I guess, more specifically. And then it pulls on the contactor down below to cause these to make contact. Now you have normally open and normally closed contacts on the side. I don't know which is which right offhand. It doesn't matter. We're just going to make it click. And to do that, first thing we need to locate and assess if it has a diode, and it does. See that big blue band on that diode? That's positive. So it's kind of hard to make contact because of this connector I put on here for a little bit more safety, but I'm going to do it the best I can and hopefully get this in focus and not create too many shadows with my my light over here. So let's Let's make it click, and let's see if I can get that to where you can see it. There we go. It shouldn't be chattering like that. That's just me not being able to make. There we go. All right, that's pretty neat. So I found some old LEDs from Solar Lights, and I think they were paired with 2 AA batteries, like the rechargeable kind. So they would be 1.2 volt. Probably nickel cadmium is based on how old they are. So I'm looking for a 3.35 volt output, and I think it was right here. I just double checking my work. 3.35 volts is what that shows. I have no idea if that's in frame, but there you go, 3.35 volts. So let's take this and see if they blow up instantly or if they don't light up at all. In my case, green is positive. So I just need a negative wire for the white, and this one should go in here and light up. There we go. Yeah, I mean, the versatility is just kind of, you know, pretty crazy with these things, especially with all these types of outputs and all they'll do. All right, well, I hope you enjoyed that little quick kind of run through of some of the things capable with these. The sky's really the limit when it comes to these power supplies. This one's more limited. It's 12 volt. It had a 12 volt motherboard, and everything that was in this Acer computer was powered with 12 volts. So really, I just wanted to show you how to power it up and get a reading from the pins. But this is just going to be if you've got some 12 volt lights. A lot of strip lights and everything are 12 volt. So really good option, and it can hold a lot of current, or it can output a lot of current. But anyway, much more versatile with this ATX power supply. A lot of different voltages. So I recommend if you can pick one of these up. A lot of times you can find junk computers at yard sales for next to nothing and just pull the power supply out of them and use it. It's a really cool alternative to having to buy your own benchtop power supply. A little bit of work, a little bit of soldering, a little bit of fun. You can have one of these and power almost anything DC current wise that you'll need in your shop. And you can mix and match voltages too, and you can do some things that's pretty cool with it. Yeah. So we'll talk about series and parallel maybe on a different video, but you can do some serious stuff with this too, up your voltage. Thanks for watching.